Hello everyone. The discussion here is on the course which is basically on electronics and communication engineering, that is called to be as ECE, electronics and what communication engineering. Now what is basically the electronics and communication engineering? In electronics and communication engineering we'll discuss about the electronics. There's the electronics and electrical here it is, and there are different domains in the engineering. Very much domains in the engineering. Electronics is one of them. In electronics, we will discuss about the digital and analog electronics measurements. We will also discuss. We will discuss about the multiplexers. We will discuss about the microprocessors, microcontrollers, digital electronics, analog electronics, and we'll discuss about antenna. We'll discuss about mobile technology. We'll discuss about microwaves. So these are some of the topics we will discuss, and the VLSI design and VLSI technology we will discuss. There are many more topics we will discuss here in this the discussion which is going on in this communication and electronics, radar and navigation, sonar. So that we are going to discuss antenna. The discussion will be on these topics, and radio frequency, what is frequency basically. So these are some of the core area aspects of what electronics. So here what we are going to discuss, the discussion is on what digital and analog electronics, and what is basically the communication, what is basically the communication is, what basically the communication engineering is. So we are going to discuss here with. So what is communication basically the engineering, and because electronics and communication constitutes with either electronics as well as communication. So here we have in digital electronics, first we will study on the number system. What are hexadecimal numbers, what are decimal numbers, what are octal numbers, what are binary numbers. Binary numbers, they will work either on 0 and 1. They will work either on what? 0 and 1. Binary numbers, they are working on 0 and 1, that is why they are called as binary. Logic 0 or logic 1, high or low, likewise. So they are called binary. Bi means 2, and binary means the number or the labelings, they are having either 0, either 1, high or low something. So this is treated to be as the digital ladder, that is called number system and Boolean algebra. And the Boolean algebra, we will study the commutative law, associative law, distributive law. We will study about the logic gates. We will discuss about the universal gates. NAND and NOR gates, they are what? They are universal gates called, because by that gates many of the other gates may be formed, and gates, they are having input and the circuitry and the logic attached, and then output is there. So this is what all about we'll discuss in this Boolean algebra and number system, and what are the associative properties of the Boolean algebra. The discussion will go here. What are now the combinational circuit? Combinational circuits, they are not having memory, or they are called to be as memoryless. Means they are working on present systems. They are present systems. They are not having a sequence. They are not having any kind of sequence attached with them. Those circuitries, they are not having any kind of sequence attached to them. They are termed to be as combinational, a combination with this. Any kind of circuit which formed with the combination of someone, that is why it is called combinational circuit. That may be encoder, that may be decoder, multiplexer also, and demultiplexer also, mux or demux we will call. Encoder definitely used for some encoding something, having some code. Decoder to detach with some code, that is why that circuit is used. Mux and demux is used. We will discuss one by one, I mean thoroughly with their logic diagrams, their truth tables also, and their what, their final diagrams, and what are their applications. We'll discuss in the what is their implementation aspects in the industry, electronic industry. The discussion will go on like this. So sequential circuit, why these are called sequential? Because they followed some sequence to be addressed. That is why they are called to be as the sequential circuit, and they are having memory. They are having what? Memory. They are having memory, that is why they are sequential. That is why they are having some sequence attached with them. That is why they are called to be as sequential circuits. And sequential circuits may be synchronous. That may be synchronous sequential circuit, and that may be asynchronous sequential circuit. Synchronous sequential circuit comes under what? Register is a synchronous sequential circuit. Register is used for the purpose of having some data inside it. So that is a memory element also, that is working as a memory element, which we are discussing here in the memory section. Counter is to count something, adder is to add something, and subtractor is to subtract something. So adder may be full adder, maybe half adder, subtractor may be full adder, full subtractor, maybe half subtractor also. They all comes what they cause they cause under the category of synchronous sequential circuit. So what is asynchronous sequential circuit? Latches. Latches here means lock. In Hindi it is called tala. So latches means a circuit which is behaving like a latch. What is latch? And what is race around conditions? Race around condition is the one when both the inputs and when the output and its complement, they both are supposed to be either 1 1 or 0 0. That is called race around condition, or the condition where one state is racing for some other state also, that is called race around. Frequent changing state from 1 to 0, 0 to 1, 0 to 1, that is the destabilizing state, is also called race around condition, because it is going to race something for getting either from 0 to 1, 1 to 0. That is why how this kind of circuits and the conditions, they can be attached and dealt in the electronic circuit. We'll also discuss about the hazards. What are the hazards, what are the hazards and havocs that may come in the electronic circuits while studying, while having some power supply in them. So that is why that is called hazards. So hazards may encompass or consist of the loss of information. There will be an information loss due to the hazards also. That is why this is of quite significant in nature significance. So here we have also in digital the memory. What is memory? Random access memory, read-only memory, PLA, programmable logical array, and PLA and PL. So these are some of the topics which are generally asked either in digital electronics, or they are of prime importance either in industry, either in anywhere of the knowledge point of view. So these are of what common concern. Now the analog electronics, that constitutes with what? Semiconductors, conductors and insulators. So what are these? Here we have a diagram which is called a band diagram. Band theory of what? Semiconductor, conductor and insulator. Here we have two type of band, that is called conduction band and valence band and conduction band. From conduction band, valence band is there. So here there is a no gap between conduction band and valence band. Here is a low gap between valence band and conduction band. There is a medium size gap between valence band and conduction band, and there is a much more gap in between valence band and conduction band in case of insulator. There is no energy gap between valence band and conduction band in conductors. It means that there is a transfer of electrons from one band to another band so easily. There is no need of energy that has to be needed to electrons to jump from this band to this band. So that is why it is called conductor, that conducts electricity. That is why it is called conductor. What is insulator? That is not going to conduct either. Whatever amount of energy that has been given to the electron, they are not going to jump from one band to another band also, but due to some conditions, a conductor that may work as a material that may work as a conductor, that is called semiconductor. In Hindi it is called, conductor means chalak, insulator means kuchalak, and semiconductor means ardhachalak. They are going to what? Conduct after imparting some energy within. So that is why they are called semiconductors. Semiconductor, the energy gap is in between what? Conductor and insulator. Which one is having much gap? Insulator is having very much gap. The least amount of gap is in the conductor, at least 0 or least very, very negligible. And semiconductor is having a gap between the conductor and the insulator likewise. Here we also discussed in this electronics diode. So if we will discuss about the diode, we will also discuss the PN junction diode. We will discuss here the PN junction diode, let us suppose PN, and we will discuss here the forward bias and reverse bias. What is forward bias and reverse bias? Forward bias is the condition where the diodes conduct on, and reverse bias is the condition where the diode will not on off or non-conductor, that is called for reverse bias condition of diode. So what is transistor? Transistor is having what? BJT as well as FET, field effect transistor, as well as bipolar junction transistor we will study in this analog electronics. Operational amplifier. Amplifier means to amplify some input and out at the output. And so suppose here is an input, and after passing through the amplifier, this is getting much more. So that is why it is called amplification process that has to be held. So that is why this is the operational means during the operation, that amplification, that modification and manipulation and magnification should be imparted to the input analog signal, that the output will be much more. That is why it is called operational amplifier. And what is oscillator? Oscillator is the one which is going to oscillate the input, oscillate the what input within, that is called to be as what? Oscillator. So we are working on these digital and analog electronics in the electronic portion of this electronics and communication. Likewise other subjects as well, because other subject we also cover in the some more domain also, but in context to electronics and communication, what are those subjects we'll discuss as well. So what is now the communication engine? Here this is very important, because communication, that may be what? That may be analog communication, that may be analog communication, that may be digital communication as well. So ACOM and DCOM, what the ACOM and what is analog communication, what is digital communication. Generally what communication means? Communication means prasaran, propagation. What kind of propagation? What kind of propagation, and what for what variable the propagation may occur? That is of information. Information, some information is there, so the transfer of information or sending of information from source to destination, that constitutes communication. And what is the block diagram? For holding a good amount of communication, definitely the information should be transferred from source to destination. So what is the block diagram of the communication? Here we have a transmitter, here we have a receiver. Likewise, suppose information source is there, and that source is going to convert it into electrical and electronics, one energy into electrical energy, let us suppose by the transducer. That is why it is called source transducer, because it is holding here in this transmitter section. That is why transmitter is constituted by the information which is getting to be propagate, and the converting device which is going to convert it into one energy into another energy, that is source transducer. Here one more, receiving transducer is to catch that information in terms of some other thing, decode. Here encoding is there, here decoding is there, here multiplexing is there, here demultiplexing is there. So through some channel, this is some channel, that medium may be air, that medium may be some wired, that may be wireless also. So this one, that will be digital, that will be analog means also. So here the destination is there where information is needed to be addressed. So here we have the receiver section where the receiving transducer and destination would be there. So likewise, if completely or absolutely cumulatively if you'll see, this will all constitute towards the communication engineering, where we are going to have some bandwidth also. What is the bandwidth? Bandwidth is the for a transmission of signal to very much long distance through free space or modulation has to be used. So likewise, bandwidth means how much type of, what kind of band that is going to used in between the transmission of information from source to final destination or sync point. So that is why it is called to be as the bandwidth of the communication. So here it constitutes with today's this lecture or the discussion that what electronics on communication engineering is. However, there are many more subjects and correlations, because every subject is correlated and interrelated in engineering. So that is why in context to in continuation to this electronics and communication, we have the digital as well as electronics, analog electronics, likewise communication here in this, the discussion will be here in this communication engineering.